So 2018 is done. Today we are going to discuss take 2020 past paper. 2020 past paper. 2020. 2020 fourth structured essay. That is a very good question. Please check it. This question will help you to understand the three laws of Newton. Two thousand twenty fourth structured essay. Okay, now read the question. In an activity to demonstrate Newton's law, a trolley connected to two equal masses M with strings is used. The figure shows three instances in their activity. They have given three instances. In those instances, the slack string are represented by wavy line, while the taut string are represented by straight line. The strings are made to pass over two smooth pulleys A and B fixed to the two ends of a table. Arrows indicated the direction of motion of the trolley, which smoothly moves on the horizontal table, and the direction of motion of the masses. Okay, before reading the questions, you should know what is slack string and taut string. What is slack and what is taut? Taut means the string in tension. Now, taut means string have tension or string with tension. String with tension. What is slack string? String without tension. Now, I'm going to take a string and then I'm going to pull this from both the sides. I'm going to pull the string from both the sides. So the string will have a tension. String will have a tension. Now here I have an object. I'm going to connect a string for this. I'm going to connect a string. This is a string. I'm going to hold the string and then I'm going to give a force. This is a small string. This is a short string. And then to this string, I'm giving a force. I'm giving a force to this string. So when I apply a force, there will be tension on the string. This tension only will pull the box in the forward direction. When I apply a force, because this is a short string, there will be tension in the string. This tension will pull the box. This is what is known as taut string, the string with tension. Now, what is this slack string? string without tension. Here, I have a very long string. I have a very long string, and then I'm not giving any force for this. I'm not stretching it. I'm just keeping it. This is a very long string. I'm going to just touch it. As it is a very long string, the string will group like this, and it will group like this, and this is how the select string will be. There won't be any tension. Here, I'm not pulling it. I'm just touching it. When I just touch it, because this is a long string, there will be a bend like this now. There is no any tension in that string. So I have an object here. I have connected a string. This is a very long string. And then I'm giving a force. And as it is a very long string, this is not enough to give a force to this object. The string will be like this. String will group down, and I have given a very small force. So this will not stretch the string. I have given small force. This small force will not stretch the string, will not stretch the string. Therefore, there won't be any force in the box. There won't be any force in the box because it is a slack string. String without tension. If tension is zero, if tension zero, no force act on the box. Therefore, box will not move in the forward direction. The Yeah. Now let us take a rubber band relief. Now I have taken a long rubber band. I have just touched the both the ends. At that instance, the rubber band is a slack rubber band. Rubber band without a tension. But that is a slack rubber band. But when I stretch that rubber, the rubber will have a tension. That rubber is known as taut rubber. This is what is taut string and slack string. If you don't know about it, please write a note. I'm going to clean this, take a screenshot and note it down. So in the question they have said, if the strings are shown like this as a wavy pattern, if the strings are shown in this wavy pattern, then the string is slack string. If the string is shown like a straight line, then this is a taut string. Taut string. That is what is said in the paragraph given. So now we'll read the question. Three instances are given. Inserting appropriately the terms given in the following box, complete the following table, which describes the nature of motion of the trolley in instance 1, 2, and 3. Instance 1, 2, and 3. In the first instance, moving is the problem. Here there is a pulley connected. Here also there is a pulley. The string is passing over this pulley. Is connected to box. Connected to box. And this is connected to a mass. M. It means there will be mg. Because it's m, there will be a weight in the downward direction, that is mg. This is instance number 1. What is instance number 2? This is a wave string. Second instance, both are wave string. Why in both the instance wave string, the box the box M is in contact with the surface. Because this M is in contact with the surface, we like this now. M is in contact with the surface, there won't be any tension in the string. It is also in contact with the surface. It is also in contact with the surface. In third instance, it's like this. There will be Mg connected to box, and it's a slack string. It means it's in contact with the surface. Here we have M. This is what is given. So here, let me put the motion, the direction of motion. Here the box is moving in this direction. Pulley is moving in the clockwise direction. This is clockwise. This is anti-clockwise. The pulley is rotating in the clockwise direction. And the box is moving down. In the second instance, the box is moving in the forward direction. In the third instance, it is moving up. That is moving up. This is moving in the clockwise direction. This is clockwise. Clockwise. This is clockwise. 12, 1, 2, 3. This is clockwise. The opposite side is anti-clockwise. And yeah, the object is in this motion. Now, in the first instance, what is going to happen? This string will not have tension now because this is a wavy string. If it is a wavy string, that is a taut string. If it is a taut string, then tension is 0. If tension is 0, the force will not be acting in this direction. There won't be any force. Tension is equal to 0. There won't be any force to this box in the backward direction. In the forward direction, here we can see this is a what string? Taut string. If taut string means there will be a tension. There will be a tension. What is the tension? Here we can see this box will have a weight in the downward direction, that is mg. Therefore, this box, because this mass has an mg weight in the downward direction, it has an external force. It has an external unbalanced force. There will be a tension here T1, and here there will be a tension T1. This force will move along the string and it will remain the same. The tension along the string will remain same. Okay. So this box will have a mg force in the downward direction and T1 force in the upward direction. How do you know mg is greater than T1? How do you know mg is greater than T1? By the use of this arrow. It is said the arrow shows the direction of motion of m. Because the arrow is showing downwards, it is obvious that mg is greater than T1. Then only the object will not move down. If T1 is greater than mg, the mass m will move upward. Now, as the force m moves downwards, as it is this object, this trolley is connected to this mass m with a string, and the string is a taut string. Because it has a force on the string, the same force will be acting on the trolley. Therefore, this trolley will be accelerating in the forward direction. Trolley will be accelerating in the forward direction. No any force in the backward direction. There is a force. Because there is a force, there will be acceleration. What is this law? This is Newton's second law. If there is a force, there will be acceleration in the body. This is Newton's second law. So what is happening to this trolley? Trolley is uniformly accelerating in the forward direction. In the second instance, this is second instance, and this is third instance. This is instance number 2. This is instance number 3. In the second instance, what's going to happen? Both the strings are wavy. It means both the strings doesn't have any force. So now you will ask, how can this trolley, now in the question it is said, trolley is moving in the forward direction. If there is no any force acting on the trolley, how will the trolley will move? You will ask, you will have a doubt. But you know, the force is not acting only, the force is not acting in the both direction. Here, force acts only in one direction, only this string has a tension. Therefore, a force will be acting on this trolley accelerate. But here if you see, both the strings are wavy. Both the masses are in contact with the surface. Therefore, tension is 0. Tension 0. Here also, tension 0. If tension 0, then here tension is equal to 0. Tension is equal to 0. Here you can see the external unbalanced force is 0. Unbalanced force is 0. If unbalanced force is 0, what can you say? Acceleration 0. If acceleration 0, how will be the motion? It will be a uniform motion, or the trolley will be moving with a uniform velocity, constant velocity. Because there is no any unbalanced force acting on the object will be moving with a constant velocity. So this is Newton's second law. What is Newton's second law? The object in motion will be in the same motion until an unbalanced force acting on the object. Here, unbalanced force doesn't act on this object. The force is 0. Because the force is 0, the object in this motion will be at the same motion. If there is no any unbalanced force acting on the object at rest will be at rest. Object in motion will travel with uniform velocity. Here the object is in motion. This motion will be a uniform velocity. So what is this law? This is Newton's first law. Newton's first law. In this instance, you see third instance is opposite of first instance. Trolley is moving in this direction. Here you can see M is in contact with the surface. If M is in contact with the surface, here tension is 0. If tension is 0, here also tension 0. There won't be any force to this object in the forward direction. But you see this mg, the mg is moving in the upward direction. Here there will be a tension T2, right? There will be a tension T2 for this object. This mass is not in contact with the surface. Therefore, this will have a force in the downward direction, that is mg. it will be have its own weight, right? This weight is mg, and there will be a tension T2 in the upward direction. Because it has a tension T2, the object will have a tension T2. The trolley will have a tension T2. Now, what can you say about T2 and mg? Now, you can say that T2 is greater than mg. How can you say T2 greater than mg? Because the mass is moving in the upward direction. This mass can move in the upward direction only when T2 is greater than mg. Therefore, you can see the trolley is moving in the forward direction. A force is acting in the backward direction. So what will happen to this motion? The force acting is opposite to the direction of motion. The direction of motion is forward. Direction of force is backward. Therefore, this will be decelerating. There will be deceleration. The object will be accelerating. The object will be moving with uniform velocity. Here, the trolley will be decelerating. This is the motion. I have explained to you completely. So, fill the table. To see instant number 1, what is the nature of motion of the trolley? Trolley will be uniformly accelerating. Trolley will be uniformly accelerating. And Newton's law that describes the nature of motion of the trolley, that is Newton's second law. Newton's second law. In the second instance, the trolley is moving with uniform velocity. And what is the law applied? It is Newton's second law. Sorry. Yeah, Newton's first law. Newton's first law is applied. And the third instance, you see the term given in the box, uniform retardation. So you should write that term. You cannot write deceleration or deacceleration. You cannot write those things. You should write uniform retardation. That is the term given in the box above. And Newton's law, yeah, in the next one they have given the answer. Newton's second law. It's Newton's second law, right? Here, this is what is happening here. This is Newton's second law. Here also Newton's second law. So the each answers you have given is 1 mark. So for the table only, you will get 5 marks. 5 marks total you will get. So this is it. Draw the diagram, write the explanation. I hope you understood it. I'm going to clean this. See the next part, B part. The figure shows a cuboidal block of wood used to examine how the frictional force between a horizontal surface and an object placed on it changes. The block of wood is connected to a Newton balance by a string and a horizontal external force F is applied. The experiment is conducted by increasing the value of the force F gradually from 0. Name the force indicated by R and W. You know what is R and what is W. Now, when here is the surface, I'm going to just keep an object. If I just keep now, this box will be in contact with the surface, but in order to mark the forces accurately, at the exact point, I have drawn it with a space. Now here, there will be an mg force. Now let us take this, its weight is m. Therefore, there will be a force in the downward direction, that is mg. on this box. No, there will be an mg force. And also, according to Newton's third law, when an object is in contact with another object, there will be equal and opposite force. This mg, this weight, this mass will push the surface downward, and this surface will push the block in the upward direction. That is what is. I have, in order to mark this force exactly, I have drawn it with a space, so you can easily get. But how will it looks like? This is how it looks like. This is how it looks like. And this R will start from here. From here. It will contact. R downward, R upward, and mg will be acting on the center of gravity of the. Now it is been said that it is a cuboidal block. You see where they have started this W and where they have started this R. Here, they have marked W from here. Actually, this W and R will be on the same line, okay? Those are collinear forces. But in order to explain it to you, I'm going to mark this here. Now, center of gravity. That is something called center of gravity. The center of gravity, the force will be acting on the center of gravity of the object. Now, if I take a box, if I take a cube like this, the center of gravity will be zero. I'm going to draw a diagonal here. I'm going to draw another diagonal. The point where they meet is the center of gravity of the cube. Likewise, for cuboid is also the same. Center of gravity will be here. So mg will be acting in the downward direction. And from where will this R starts from? R starts from here. The point in contact with the ground. R starts from here. Actually, you should draw like this. R and W will be collinear. So what is R? R is normal reaction or perpendicular reaction. What is W? W is weight. W is weight. So B, what's the marks? Yeah, for writing normal reaction, 1 mark. For writing weight, another 1 mark. Now see Roman number 2. A block of wood stays at rest until F is increased to a certain value from 0. By what name is the frictional force acting on the block of wood known before it starts to move? Before it starts to move. So, when the block is not moving by giving a force, the given force is less than static friction. Now, when the object is at rest, there will be a force, that is friction will be acting. So I'm going to give a force F. If force is greater than F for only the object will move. If F are less than F, sorry, if F are greater than F, no motion. So before it start to move, the friction acting is static friction. Friction acting when the object is at rest, that is static friction. Static frictional force. For that, I have given 1 mark. At the moment the motion starts, the frictional force acting on the block of wood reaches the maximum value. So this is the graph. I explained to you this graph so many times. From here to here, static friction will be acting. At this point, limiting friction will be acting. That is the maximum static. That is the maximum static friction or the limiting friction point, and this is dynamic friction. So when the object just starts to move, the maximum value of friction will be acting. That friction is static friction, sorry, limiting friction. Limiting frictional force. For that they have given 1 mark. Write to see P part. Write two factors on which the magnitude of that frictional force depends on. Yeah, the frictional force depends on two factors. What is it? Nature of the surface and the normal reaction or perpendicular reaction. So for writing those two, yeah, write two factors now. For one factor, 1 mark, another factor, another mark. Suggest a method that can be practically applied to change one factor you stated in B above. Suggest a method that can be practically applied to change one factor you stated in B above. Now, what are the two factors? Nature of the contact surface and the normal reaction. How can you how can you change the nature? How can you change the nature of the surface in order to change one factor? What can you do? To change one factor, what can you do? How can surface mean contact surface? You know that there are two surfaces, smooth surface and rough surface. Smooth surface and rough surface. If the surface is rough, how are you going to change? Change in the sense this rough surface should be converted to smooth surface. Rough surface should be converted to smooth surface. Or smooth surface converted to rough surface. It can be in two ways. Now, how can you change this rough surface to smooth surface? By using a sandpaper. Sandpaper, if you scrub the surface will become smooth. The surface will become smooth. Therefore, friction reduces. Therefore, one factor, the how can you change the nature of the contact? How can you change this factor? This factor in the sense, nature of the contact surface with the use of sandpaper. If you scrub it, the nature of the surface will change from rough to smooth. And also, from rough surface to smooth surface, you can change by applying the powder. Now in the carom board, if the surface is rough, you apply boric powder. Therefore, the disc will move faster. Why is that? Friction reduces. Therefore, from changing the sorry, contact surface to rough surface to smooth surface, you can apply powder. That is one technique. What is another technique? I said you the friction depends on surface and the normal reaction. This is done now. How can you increase the normal reaction? Here, I have a weight. Let us take mg. Sorry, the mass is m, simple m. So there will be mg and there will be a normal reaction. If I add some more weight to it, now let us this n now. I'm going to add another weight. So what is the total weight acting? 2 mg. This is m, this is m. Because of this, there will be a weight mg. Because of this, there will be a weight mg in the downward direction. Therefore, here mg, mg, this mg will create 2 mg on the surface. Okay. Therefore, both the box will give a 2 mg force in the downward direction. What this force will do? E is exerting 2 mg to the surface in the downward direction. This surface will let 2 mg force from the surface to the object. Here mg will be active. Here 2 mg will be active. Okay. So by 2, we can change the factors. One technique for this one, another technique for this one. We will see the answers given. A technique such as applying sandpaper or powder to change the nature of the contact surface. That is one technique. Second technique, techniques such as placing any mass on the wooden block to change the normal reaction. Placing a mass on the block of wood to change the normal reaction. Initially it's mg, now it's 2 mg. If you add another mass, then 3 mg. If you add another mass, 4 mg. Likewise, by adding mass on top of it, we can change the normal reaction. If normal reaction changes, you know the equation, friction is equal to mu into R. This is a constant, no? This is a constant. If R increases, then the friction will increase. This is a constant. Therefore, if R increases, that is, Fr means friction, right? Fr is directly proportional to R. If I increase this by 2 times, friction increase by 2 times. If I increase this by 3 times, this increase by 3 times. Okay, therefore, that is it. Question finished. Any important points, mark it. Now you must have a good knowledge under friction. There are 2 more questions also. We'll discuss it after that. Friction, so the first part is done.